Looks like we're on. Okay. Yeah, looks like everything is all right. A bit of a sanity check.
All right, sorry for the,
Sorry, yeah, for
the inconvenience, technical details. We're not engineers, we are actually. But that's and we have feedback. We need to mute probably.
Are you also in the meeting? Maybe. Okay, just make sure that you have your mic off, because we're getting from your mic here. Yeah, nice.
Okay, so colleague here, Guilherme Cassolato. I'm Didier Di Cesare. Even though like both of us, we have like Italian last name, we are not Italian. And we are here to present you the data privacy and application security through Kubernetes Gateway Policies.
Yeah, as Rael said, we're both from the Quadrant team at Red Hat, members of the Quadrant team. And a little bit of a disclaimer here, or a few of them actually. Number one, even though the title says data privacy and application security through Kubernetes gateways, neither Didier nor myself consider experts in any of those areas, data privacy or application security.
10,000 hours to be an expert. Yeah. And as you can see, we are in our mid-20s, so that doesn't add up.
If anything, we've been acquiring some experience with Kubernetes Gateway Policies throughout the past few years, right? And another one, prepare yourself for a bit of a jump on the network stack compared to the previous talk, like from L4 more to mainly L7 layer, right?
Yep.
And, well, already said, not experts. We're not here to sell any product, right? We're associated with the Quadrant project, but rather what we really want here is to discuss an architecture composed of a few pieces of technology that we've been learning to have great potential for tackling issues within those two areas, data privacy and app security.
Not selling, you're in Red Hat office, so somehow we needed to push like at least for upstream project name.
So we're not selling, but we're not, right? So a bit of an acknowledgement, right? Data privacy and app security are way too big of two areas for us to cover here. So
conference is needed for each of these topics.
Absolutely. Sure. So instead, what we'll be doing is we'll be focusing on specific issues within those areas, right? Driven by some background user story that we have here, okay?
So the user stories is this one. This is actually how we depict it. Imagine that you have like an enterprise big, you're expanding to a new region, say like we are in the US, and somehow we cannot replicate the workload because of policies, because of money, because of many things. And we need to reduce the personally identifiable information exposure. That's what the PII stands for. And that diagram simplifies the use case here of a cluster running in the US, and they want to expand to a new zone, EU, let's say.
Yeah, correct. So this is the current state of things. This company has a cluster based in the US. It's opening this second cluster here. The service workload, as Didier said, is running only on the US cluster. Cannot replicate to all the clusters, right? To the region, the different reasons, the architecture or costs, constraints, whatever. So rather, what they want is this new cluster just to be able to receive traffic incoming from this region, but then redirect the traffic, send the traffic to the service workload running in the main cluster.
We are familiar with this in Europe in general, and
because,
consuming US services.
So yeah, because we are crossing regions now, so we need to be concerned about personally identifiable information, right? User that allows to identify the user, like contact information, this kind of information, right? And make sure that we are not exposing this kind of information across the different regions. Also, make sure that there's some isolation between the regions, right? Different set of users, different policies can be enforced in different clusters here. Also, we want to make sure to have cross-region traffic authentication.
And we're going to, it's actually a really good opportunity to tackle and actually attempt to mitigate DOS and DDoS, because we know that it's actually almost impossible fully.
Taking advantage that we're reviewing the architecture for the new topology, try to harden a little bit, the countermeasures to protect against DDoS kind of attacks, right? So to call out here, again, the specific issues within those areas that we'll be focusing on inside of data privacy, the limitation of the propagation on the personally identifiable information, PII for short, across sites, right? And in app security, we'll be focusing on cross-site authentication and authorization and mitigation of denial of service and distributed denial of service risks. Okay.
So we need to establish somehow like a baseline here in terms of like the topics that we're going to be talking about and what it stands for. We already talked about like PII. And imagine that your name, your email, your phone number, your handler, Mastodon, please, with X, and anything related to that is going to be identifying you. So, and about regarding authentication, authorization. So authentication is like this actually authenticates me. It's like your tag is, okay, you're Alejandro, Roberto, David. So, but you possibly with that cannot enter all the other rooms. That would be the authorization part.
Yeah, this is a little bit of knowledge leveling here, right? Because we will be referring to some of those concepts throughout the presentation, make sure that we are everybody on the same page here, right? So, I think most of it are familiar to most of the people here in this room, right? But just make sure when we say denial of service, we're referring to that kind of software security threat where a malicious user attempts to disrupt the system in a way that the system can no longer provide services to a legit request to a legit user, right? And the distributed denial of service, or DDoS, is kind of a special form of it where the requests are distributed and coming from multiple sources, right? There are different ways to exploit this kind of vulnerability in systems, either by flooding your system with way more requests than it can handle, right? In a way that the system is too busy handling that load and cannot have to give up on serving legit users. But it doesn't have to come to that, right? Sometimes one single request that happens to activate a deadly bug, causing the system to lock down for legit users is already enough to characterize denial of service attack, right?
Then we have like traffic coming from north-south, ingress traffic, whatever comes from the internet to your cluster, into your cluster, and then whatever inside your network, the services communicating, that will be defined as east-west traffic. And most probably the most, new thing that probably for some of you do you know what are familiar with the Gateway API? Okay.
Cool.
Right, this is amazing. Next slide is on me.
Yeah. By the way, we may be jaggering like this all the time throughout the presentation, only so you can it look like you're watching a ping pong game, right? Sorry about that. Yeah.
So in this diagram, Gateway API is an open source project driven by the SIG network, which
by the way, stands for Special Interest Group, right? It's the kind of special groups in the Kubernetes community that is focused in a particular area of development of Kubernetes.
Yeah, like
there is
many.
one for Gateway API, yeah.
There are many driven around like satellites to Kubernetes. So as the Gateway API, as the name stands, API, like a set of resources, in this case, going to be Kubernetes objects. And so why they came out with this thing? So they wanted to replace initially the ingress object that you might be familiar with, and with having more thought on it, since it was actually first to the ingress object, it was north-south traffic. And then the service mesh community said, wow, this is actually looking really promising. So why don't we extend it to east-west as well? So they fully cover all the network aspects, and they have some premises in mind. So it needs to be role-oriented. You can see here that there are different personas that they're going to be in an organization. They're going to be working on different aspects of the networking in Kubernetes. We have the infrastructure, gateway provider, platform engineer, application developer, within others. It needed to be extensible. So you can define your own CRDs and attach to them to expose new features. In this case, there's actually a new pattern, which is the policy attachment, which lets you define a specific set of instructions to enhance these networking objects. If it's actually attached to one object, it's going to be direct policy attachment. If you want to attach it to a set of objects in a hierarchical way, that would be the inherit policy attachment.
Yeah.
Then we have another particularity of it, that it needs to be expressive in a way enough just to define many things about the traffic. And it is a good thing because normally in the way that you will do this in ingress objects is with adding custom annotations. So it is actually a bit of a pain. And the most important thing when you define a new standard is to be portable. So that means that you will be working on the specification of these objects, and the implementation relies on whatever vendor that wants to implement it. There are many. So same specification, especially in particular when you are trying new technology, you can be switching through those vendors very easily.
Yeah, in similarity to the Ingress API, it has the fact that just like in the Ingress, you can create an Ingress object, but you still depend on the Ingress controller to deploy the actual workload, right? To give the functionality for that object. It behaves in the same way, right? That is a similarity with the Ingress API. But it's a hell of an improvement compared to Ingress, right? Didier mentioned how rigid the Ingress API regarding extensibility, right? It's very hard to extend, leading to that problem of the explosion of annotations always stuffed into the Ingress object. So the different Ingress controllers can pick up from there and shape the implementation accordingly, right? Yeah. Here, they are tackling this problem in different ways, right? One is by splitting creating some separation of concerns here. So you have these different kinds of resources. The gateway, which is usually owned by platform engineers, it's where you usually define, where you define your listeners, your top-level domains, right? So this aspect of your gateways. Then the gateway is based on a gateway class, which is owned by an infrastructure or a gateway provider, right? So it also comes with some specificities of that particular gateway provider. It contains extension options to shape how all those gateways based on that class will behave. Yeah,
let's put it that way.
Yeah.
Then we have like HTTP routes, gRPC routes, and TCP routes. These are actually protocol-specific way to connect the traffic coming to the gateway to those Kubernetes services.
Yeah, correct. And for example, in an HTTP route, you can define some HTTP matching rules that define basically how the traffic flowing through that gateway into that HTTP route will effectively be directed to a backend service. Right? There are some built-in functionalities compared to Ingress that are quite nice to see. For example, filters that you can enable on HTTP routes, right? All a part of the gateway API.
And the policies that, thanks to the policy attachment pattern, then lets you define yet another persona that could be the policy manager. And those would be enhancing the gateway API objects.
Yeah.
And pretty much that's it that we can say about the gateway API.
Yeah, it's not clear that still this policy, it's sometimes called meta resource, right? It's a kind of resource that is meant to augment the functionality of the resources it attaches to. So here it's represented a policy that's attached to a gateway, another policy attached to an HTTP route, but gateway API is generic enough to support all different kinds of attachments.
Maybe you're more familiar with filters.
I think policy provides a more flexible way to extend the functionality of those resources, but there are things that deserve to be represented in the form of filters and part of the API.
Good.
Yeah, cool. So now finally, this is the architecture we'll be talking about, right? So you can think of this as a more detailed version of the previous diagram that we showed when we were stating the problem, right? The background user story, right? So you can see here, we have on the left side, one Kubernetes cluster that is our US cluster, right? On the right-hand side, we have the EU cluster, right? That we are introducing to the architecture here. We have all the traffic incoming from the EU region goes to an ingress gateway inside of the EU cluster, Similarly, we have this on the US cluster as well, right? We have gateways, we have routes, all based on gateway API, right?
One single workload. As you can see, the Echo service represents the only workload that has and only resides within the US cluster.
Correct. This is just a simple API, only for the sake of the demo here. So it's an API that echoes back in the response. Yeah, exactly, right. But you can mentally imagine any kind of service here, right? It could be like, I don't know, some serverless function, some AI model deployed. It doesn't matter, right? This is the workload that we said before that cannot be replicated across the cluster, but rather will be only running in the US cluster, okay? You can also see here that we have Keycloak deployed in both clusters. This will be our auth server and identity provider. Hence, we have one in each one of the clusters, right? On the top, we have some control plane layer that takes care of some additional functionalities on top of the gateways for the purpose of configuring your DNS, cloud DNS service, right? So we have a DNS policy there represented attached to a gateway, abstraction. We have the TLS policy that control plane takes care of from that TLS policy to sync the TLS configuration across all the gateways across your multi-cluster environment, right? And here on the bottom, we still have all the data plane services in this case that will be responsible for enforcing, respectively, your auth policies attached either to gateways or HP routes, or your rate limit policies that you also see here presented here in the diagram. Obviously, this is not a kind of setup that you deploy in one go, but rather through a series of steps that we're not going to be going through the details here, but you're more than welcome to check that GitHub repo that we linked in the cover slide of the presentation, where you have all the steps. But you can think of this as run one script that gives you the clusters, and then, unsurprisingly, a series of YAMLs that you are applying to the cluster, right?
And you have the personas that take care of it. Actually,
yeah, some of these steps, are meant to be performed by the platform engineer, while some others by the app developer, right? So just quickly going to the point where we reviewed the architecture. Good, right. So this is it. Maybe now we can switch screens and jump to a quick demo of sending requests from both locations, right? Simulating both locations, and then we can go back to this and discuss the details of what's going on. Good. Okay, let's switch places as well. You can, swipe.
So of course, this is actually the gist that we're going to share. We're not going to deploy everything because it's going to take several minutes, and we don't have that time. But we're going to pretend that we're going to get first the access token from the Keycloak deployed in the US. Of course, I say pretend because we're going to use curl, and we are not going to let DNS to resolve the address. We're going just to give the IP.
This is because obviously we'll be sending all the commands from the same machine here, right? We're not making one of those passing through any gate or VPN or anything, right?
So this is VS Code, an amazing plugin that Guy developed, and you can click execute the command, and you get the response within your VS Code. So pretty good in the preview.
By the way, this was just requesting to the Keycloak server in the US region for a token, right? So authenticating with a user called John. And what you see here is the basics for encoded representation of that Keycloak issued access token.
Yeah.
Okay.
Of course, IP is not a really good password, but so using that token, what we're going to do is reach the Echo service within the US cluster. Of course, we're still going to use the same resolution of the IP address.
By the way, if I did not include this, obviously, because we are in Europe, we would always be hitting the Europe.
Another way just to try it out is use VPN and switching, or any other proxy, and switching the geolocation. But well,
I can also show later the AWS console, because we're using AWS Route 53 here. So when you create a DNS policy, that control plane, multi-cluster control plane, took care of configuring the DNS records in Route 53, including the, I would say, load balancing, but you rightfully pointed out during the last presentation that would not be very accurate. It's more like geo distribution of the traffic based on where the request is coming from. So
the response is at 200, okay? That's good. Set of headers here. And we're going to show you what happened with the token exchange that was behind the curtain happening in the cluster. This echo just going to show you in a very nice format the access token that we got from Keycloak. And below is going to be the access token that we call it wristband, that it was exchanged by our service, or authentication authorization service.
If you allow me to highlight here, this is the response from the echo service, right? If you notice, in the request we sent, in the authorization header, we sent a bearer token, which was the one we got from Keycloak, right? But what we actually got in the echo service is something different, right? It says authorization wristband, and it's a different token here. So I think that this is what Didier will show up, right? Demonstrate here. By the way, you can see here that we are printing the access token, and here we are printing the result of another request. That's because I'm lazy, right? Because the right thing to do would have been parsing this and showing the exact same thing, okay? But it was just easier to issue the command again.
So the access token coming from Keycloak, it has a lot of information that anyone can see if they got access to it. And in particular, we can see that John Doe did that request. That's the access token from Keycloak. And that's actually not very good in terms of mitigating the PII. So what we do is a token exchange within the cluster. And this is a token, the JOT, that we got from the cluster in the request that you saw before, in the response. As you can see, there is like nothing that could identify the user that did that.
At least not contact information, not things that are considered to be sensitive data, such as full name, email, telephone number, this kind of information.
The subject is probably the only unique thing that is going to be meaningful for within our services, but nothing for the outside internet world.
At this point, this is just an opaque identification of the user, only for the purpose of later on enforcing per user
authorization,
rate limiting.
Yeah, and rate limiting. So we're going to get now an access token from Keycloak, from Europe, the cluster in Europe. Of course, we're going to still tell curl to resolve the address to this particular IP, different from the other one. That's the one that we're going to show you later, coming from route 53. We got the output. It's a different token.
Yeah, it's for a different user. Yeah, different Keycloak server.
So
a different token. Yeah.
We have like a 200. That's good. Same information than before. And the most important thing, what it does is actually showing you that in this case, the user making that request was Jane Smith.
Yeah,
a lot of information. Yeah.
If I may point out here, if you compare to the other one, right, in the East-West token, or the one that we call the wristband, right, we are injecting some static information here. So the one we got from the token exchange in the US, you could see US here. This one says EU, right? We also have some scope. This has also to do with the aspect of security here that we'll be pointing out in a minute.
So first request went to the internal through US traffic to the US cluster. You can actually see the request here that we actually fake the region, of course.
Sorry, before you move on, only to point out, it was first in the first request to the Keycloak server, right? Because we have a gateway API HP route that specify the auth.hostname. So this the request was sent to the Keycloak server, and the next one was to the echo service here. So passing through the East-West network there, right? And by that point, it had already validated the Keycloak access token and exchanged it for the wristband token here, which is later on validated by the East-West gateway due to the enforcement of this other policy here that requires a wrist token to consume.
That opaque identification that you saw before, it is used in this in describing this house policy and rate limit policy just to authorize and limit the request from that particular user. See, like the information that gets here, it's actually not identifiable for the actual user. And
even though, I'm sorry, in this case, we're talking all about the US, right? So it's all inside of the Keycloak token and the wristband are all inside of the same region. So it's not too much of a concern. This one is more interesting.
It's interesting. So here, on the other hand, we know that we have a lot of rules and that we need to actually adapt to that rules. And we cannot actually leak any reason information about the users, and all the data needs to stay here. So that hence we have like a different key cloak that we're going to store all the information for the users. And again, the token exchange happening at this level, and this described in this host policy. And then we are channeling the request to the East-West gateway deployed in the US and going to consuming the echo service. At that point, there is nothing defining, like identifying the user, absolutely nothing. Just that piece of
The wristband,
ID,
yeah.
the wristband, as we call it, and that's it.
Yep. Okay, allow me now to highlight in the next slide, if I may.
Yeah, go ahead.
A series of capabilities that enable the measures and countermeasures related to those two big problems that we are tackling here, right? Either the data privacy or the app security one, right? So in the data privacy, we start with the geo distribution of the traffic. So we ensure that there's some isolation of the request, either here or there, right? But most importantly, we have the token exchange that we demonstrated here, right? And the limitation of the PII inside of that second token. By the way, the ones that you see in red are things that we are not deploying in this particular deployment, but they could be very easily achieved by just editing existing policies there, or in the case of this one, rate limiting by IP, by deploying another rate limit policy attached to the ingress gateway, right? Only for practicality, we did not include these ones, but it's be as easy as just editing those YAML files there. But the reason why I'm pointing out here is because, well, distributing the load based on the DNS only goes to a point, right? I mean, it worked, but it's the kind of thing easily bypassed, just like we did here in the demonstration, right? So this works as a default, but also you may want to ensure, again, right, at the entry point of the cluster, in the ingress gateway, that you're not bypassing the distribution of traffic. So if you receive a request here, you should at least inspect the client IP and make sure that it's coming from the intended region, right? That's why I'm pointing out something here as well. As for app security, there are more stuff here, right? Remember, we are focusing on multi-cluster authentication authorization and some mitigation of those DDoS risks, right? So starting with the DDoS, I mean, it usually starts with the power of Kubernetes and the capacity, the ability to scale, right? Obviously, that is not the way you will countermeasure DDoS threats forever, right? Because for everything, there's a limit. So you can scale to a point, but you need other countermeasures as well, right? Things such as you want to rate limit by client IP. This is usually one thing that is recommended, right? But because nowadays attackers can always get some more IPs, this does not suffice, right? You're just adding, in fact, mitigating against DDoS attacks. It's a chain of identifying threats and countermeasures, and those countermeasures open up for more vulnerabilities, and you keep on doing that to a point that some people argue that it's an unsolvable problem 100%. But you can keep on doing that and refining the layers of security that you have, right? So these are the kind of things that are at play here. So what else? Also, we have authentication. All the tokens here, either the one issued by Keycloak or the one exchanged here at the entry point and in the ingress gateway, based on private and public key. So you can relatively efficiently, you can verify the token compared, for example, to having to look up some user database or going through some network of any kind, right? If not for the first one that you get from Keycloak, but at least for all the other requests, that the ones that are actually going to your Echo service, that is the main sort of concern here. Say that the user passes through, the attacker passes through the first layers of security that you have and end up breaching into the authentication layer, right? A couple of things that you can do. You want to make sure that those tokens are short-lived, right? So this is one way to reduce the scope of the attack. Also, I don't know if you noticed, but I tried to point it out in the wristband token that we have a scope.claim that we are injecting there. That basically what we're doing is making sure that later on, when this is verified, the authorization verified here, when already about to reach the Echo service, we ensure that the wristband token is only accepted for consuming that echo service. Of course, we have no other service here, but imagine a situation where we had multiple services. So you want to reduce the scope of the attack, right? And finally, we have the authenticated rate limiter that I mentioned before. Let's say an attacker passes through all those layers, right? You want to make sure that it's contained to one particular user and not to all your users, right? Well, we're not going into details here, right? But this is the chain of threats and countermeasures that I mentioned before, right? Unless you want to, we can go to this later on, right? During the rest of the event today. But basically, this is the reasoning behind all those countermeasures identified on the architecture diagram before, right?
Okay, so briefly, this is a technology that we use in this architecture, in this exploration that we did, that we presented today.
So yeah, we do not want to give the impression that it's one single thing that you apply and it takes care of everything for you. As almost all the things in real life, you have to play with the best that you can get, right?
And many other vendors as well. So so Gateway API, you can see here that is actually extensively used and consumed. We have like the HTTP route objects, we have the gateway objects, and we have the policies as well.
Yeah, the policy attachment pattern.
So, of course, we are not into the gateway businesses, so we are using Istio as a gateway implementation.
Istio is the gateway provider that we mentioned before, right? So the implementation of the gateway.
It could be any other, of course. And yes, this is us. This is Kuadrant. We are in the policy attachment business. So we define many policies, and we have services that actually understand them and ensure that those policies are applied. We have like rate limiting, authorization authentication, and DNS and TLS.
Yep.
Okay.
OCM
just for replicating the clusters.
Yeah, and synchronization of the configuration across the clusters, the multi-cluster environment.
And Scupper is actually what we're using for tunneling those requests.
Yep.
So pretty much that's it.
And I think this is our last slide. Yeah. This is it. Yep. Stop on this one too much. Maybe this one, yeah.
Any questions?
Questions? Complaints?
So Autorino was for the make-out policies, no?
Autorino is the data plane service that enforces all the old policies on the requests passing through the gateway and routes. Yes.
Yes.
Yeah, because I am working in something like that. That's why I need to.
Cool.
I need architecture decision for
nice
because we need to protect some routes and because we are creating a software. There is the admins can choose. Okay, this kind of user can go there. This kind of user can go.
That's fun. Well, actually, this is actually the solution.
But there is I need that solution because I know I need a gateway, but I need to something also understand my policies.
Okay.
What time did you spend to implement all this enforcement?
I'm sorry, come again?
What time did you spend to implement all of this?
Oh, that's a good question. I don't know.
It depends on when you conceive the idea of you have like something, a use case, and then the use case was made up by us. So it was actually quite easy to implement. Say like we've been working with similar kind of like architectures and designs in the past. So it took us, how much would you say?
I wouldn't venture a guess, actually, but I can show you something, right? Because most of the hard work is done by this script here that creates the clusters and install the stack for us, right? The main pieces of technology that we do. And this is part of our walkthrough to help people learn about Kuadrant and how it works. So this will already give you 2 Kubernetes clusters deployed with Kind. I don't know if you're familiar with Kind. It's a tool, alternative to Minikube, right? So it's a containerized Kubernetes cluster. So it creates 2 of them for you. One is the control plane. The other one is the spoke, which is terminology inherited from OCM, the Open Cluster Management project, right? And Kuadrant install a bunch of stuff for you. But later on, there are more steps that we are adding here, where we are actually creating the gateway based on Gateway API, right? Applying TLS policy the way we want, right? With the TLS later on.
DNS.
This is how a DNS policy looks like. I promise I would not be showing YAMLs. I'm so sorry for this. Yeah, gel-enabled thing, right? So
YAML engineers.
we came up with this east-west plumbing thing. So this was all us. We created another gateway, another route, right? So then comes the actual policy, right? So this is the policy for the north-south gateway. So this is basically
They're sure as well.
yeah. So the one that verifies. Yeah, it's on GitHub. Yeah. So this is right. The piece that checks for the verifies the key clock issued JOT, right? The part that takes care of the token exchange, this kind of stuff, right?
Actually, yes, I don't know the implementation and the thing that you're working, but the service, the Authorino service, it could actually work not using Consuming Gateway API. Like it's actually kind of portable.
Yeah. I can talk with my service who it's managed in a UI and can send it to the other. Say, hey, here's the policy, and they do not on live. They will be updated on live. So
right.
There's no deploy should be on live because you're no admin anymore. So fuck you.
Right.
Yeah, indeed. I mean, Authorino and Limitador, which is the counterpart for rate limiting, those are services that are independent from Gateway API, and they can be used independently, right? The reason why we did not separate from Quadrant is because Quadrant is basically wrapping Gateway API around those, and the concept of policy attachment around those.
Yeah, Authorino is developed in Golang and Limitador in Rust.
Yes. So this is the application developer deploying the Echo service, right? Nothing surprising here. Creating the auth policy that only accepts wristband tokens for that service here.
So following this guide to answer the question is going to be minutes, but I imagine in a production-ready, implementation, there are like many decisions in between actually after applying those YAMLs.
Yeah. Then there's introduction to the second cluster, a little bit more configuration. Then we are back where we first started and consuming the service. By the way, I think we did not show here, but something we could show as well is
rate limiting.
Yeah, I mean, let me make sure we get another token here from Keycloak. And if we send, I think the policy said no more than 5 requests every 10 seconds, right? So if everything works out, we have a 49. It's also rate limited.
Yes.
Right? Maybe less bit that I did not show, but I mentioned, right? So this is AWS Route 53. So when we create the DNS policy, it took care of creating the DNS records here, enabling the gel thing right on Route 53, the distributed traffic.
The A records is the ones that we were explicitly telling Carl to use in our code commands.
And and it's all, as I promised, it's all here in this GitHub repo.
Any other questions?
Yep. Do we have beers now, maybe?
No,
fantastic.
It's empty there free. I drink cold.
Oh,
shame.
Let's go.
Shame on Red Hat. Yeah. Okay.
Okay. Well, hope
Thank
you enjoyed
No.
it. Now we're going to share in the meetup. That's for sure. Actually.